Hello everybody. Now we will study in today's lecture a very important aspects of processing and preservation of fruits and vegetable products, particularly juices, pastes, concentrates, beverages, etc., and that is aseptic processing and packaging. So, aseptically processed and packaged products, fruits and vegetable products, they have gained popularity in the market as well as in the consumer mind in the recent past. So, what we will discuss today in this lecture is that aseptic processing, what is the concept of aseptic processing, then components and systems of aseptic processing line, aseptic packaging materials and systems, and then finally we will discuss about the sterilization of the aseptic packaging materials and equipment, because sterilization of the food materials we have already discussed earlier. So, same concept will be applied here as well. Okay. So, let us see what is aseptic processing and packaging. Okay. Aseptic processing and packaging is a method of preservation which refers to heating of the liquid food product, that is commercially sterilized and holding at an elevated temperature followed by cooling and filling it into a sterilized packaged and hermetically sealing with a sterilized closure in a commercially sterile environment. Okay. As you can see here in the figure, that is these are there are two lines here, one is the product line and another is the packaging material line. So, both the products and packaging material, there are the specific systems which we will discuss little later. So, the product is sterilized separately, packaging material is sterilized separately, then it is brought to the filling room and packaging room, which is maintained under an sterile environment or in an aseptic environment. So, processing and packaging and then finally filling and sealing in the aseptic environment. So, this is the whole concept of aseptic processing and packaging. Since in aseptic processing and packaging very high temperatures are employed, generally to the tune of 130 or 170 degrees Celsius. Okay. So, these processes are generally referred to as ultra high temperature processes or UHT processes, and processing at these temperature requires that the product sterilization process be based upon the enzyme inactivation, because under these high temperature ranges it has been seen that enzymes give a higher resistance than the microorganisms. So, the most of these processes are generally based upon the enzyme inactivation kinetics. Here is a system for the aseptic processing or components of aseptic processing system. So, this is aseptic processing is normally used for liquid food or even concentrate and paste also. So, obviously, there is a feed tank. In the earlier lecture, we discussed about concentration and juice extraction and paste. So, either pulp or paste or juice, whatever is, so it is brought from the its a manufacturing unit, extraction unit and concentration unit and taken into in the feed tank in the aseptic processing line. So, from the feed tank, obviously, in the processing here, this component there should be suitable pumps, that is pumps which can feed this material to the heat exchangers. So, through the appropriate pumping system, the material is from the bulk feed tank is taken to the heat exchangers, where it is exposed to the calculated time temperature combination required amount of heat that is required for giving the desired commercial sterility. So, once the material is heated, brought to the specific temperature, then it is taken to the hold tube, where it is held for the desired time, so that the complete sterility is obtained. Finally, the product is again from the hold tube, it is conveyed to the cooling line, where it is cooled, brought down and then sent to the filling and packaging line. Filling and packaging line we will discuss separately. So, let us see. So, these are the different components in the aseptic processing of the product as far as the product processing is concerned. So, obviously, as I told you, these are the liquid food pulp concentrates. So, the system should have good, that is the feed tank, a good pumping system, heat exchangers, and then cooling system. These are the main components of the aseptic processing line. So, the feed tank, obviously it is a product supply tank provided with a mixture to keep the product suspended while feeding the system, that is the proper mixing is required, so that there is not settling or solids etc. do not settle. So, a homogeneous uniform mixture is going out. The outlet of this bulk tank is connected to a pump. The level sensor of the tank is used to control the level in the tank, so that the pump does not run dry and cause unnecessary damage to the pump. Temperature in the feed tank can be controlled by having a jacketed tank or having a steam coil, okay, and coolant, that is water or ethylene glycol, can be circulated to keep the product under refrigeration, or steam can be used to keep the product at an elevated temperature as the case may be. So, all those arrangements are provided in the feed tank. Then, as I told you, that from the feed tank with the suitable pumping system, these are conveyed to the heat exchangers. Here the different pumps and schematics of the different pump, how they work is shown in the figure. So, generally food grade pump for the aseptic systems are used to push the product throughout the system, and because of the process design and lethality requirements in the hold tube, generally positive displacement provides a constant flow rate and hence a defined fluid velocity and residence time in the hold tube. So, generally positive displacement pumps are used here in this case, so that you can get a proper residence time and calculated that is temperature etc. is properly maintained, okay, and you get a proper flow rate. So, each stroke or revolution of the pump pushes a fixed amount of fluid regardless of the other factors, that it positively displaces a fixed amount of fluid in the system, and the continuous supply of the fluid in the heat exchanger is maintained. Then from the pump pushes the material into the heat exchanger. This heat exchanger basically these are the systems, that is the product sterilization and cooling systems. They may be of direct or indirect heat exchangers type. Heat exchangers equipment which are generally used in the aseptic processing line include scraped surface heat exchangers or plate heat exchangers, tubular heat exchangers, equipment involving direct steam injections etc. Right, and all these heat exchangers are arranged, particularly scraped heat exchangers, so that the material while it is being heated, that is continuously it is being scraped, so that to avoid any fouling or burning etc. of the content on the side which is direct in contact with the exchanger metals etc. all right, or plate exchanger heat exchangers could be. So, heating and cooling in the direct heat exchanger, that is the energy requirement etc. can be calculated, that is heat transfer using this Q is equal to mHCpH, Th minus Tho are equal to mc Cpc multiplied by Tco minus Tci. Other Q is the heat transfer rate, mH and mc are the mass flow rate of the hot and cold liquid. CpH and Cpc are the specific heat of the hot and cold liquid. Tco and Tci are the temperature at the exit and inlet of the cold liquid, and Tho and Thi are the temperature at the exit and inlet of the hot liquid. So, accordingly using this one can calculate what will be the heat transfer rate, and then accordingly what should be the other calculation, that is how much heat is to be required to be given to get the desired sterility can be calculated. Then the sterilization of the product in the aseptic processing, the design, it is designed to achieve commercial sterility, and this is based on the well established principles of thermal bacteriology and integrated effect of the time and temperature treatment on the spores of the microorganisms or enzymes, as the case may be, depending upon the material being sterilized. Okay. And in the earlier lectures, when we were discussing preservation by heat, we have by addition of heat, we have discussed by the theoretical aspects of the sterilization, etc., which is true here, which holds good here in this lecture as well. Okay. So, pre-sterilization of a product usually consists of heating the product to the desired UST temperature, maintaining the temperature for a given period in order to achieve the desired degree of sterility, and with subsequent cooling, usually at to ambient temperature and sometime to an elevated temperature, as the case may be, to achieve the right viscosity for filling, because that is very important, that is the material that is concentrates, etc. So, sometimes the heating is arrangement to get the proper viscosity, so that the material can be properly pumped or conveyed to the filling line. So, heating and cooling should be performed as rapidly as possible to achieve best quality depending upon the nature of the product. A fast heat exchanger rate is desired for cast regions, and since the UST processes is the order of the second, so it is very important that is the residence time, particularly the residence time in the holding tube is very important, and it must be precisely controlled to avoid any under processing or over processing. So, in this table I have tried to give you a comparison of various type of heat exchangers. For example, steam injection or steam infusion heat exchanger, if you see. So, as far as the product quality is concerned, they are excellent, but there is no aroma retention, or that is the, so most of the aroma get destroyed. Energy saving is also poor, its capital cost is high. Okay. Space requirement is fair, and even that it's a turn down, that is turn down is the capability of the system to process at different rates to accommodate different number of fillers or different packaging sizes, etc. So, this turn down is also fair. So, if you see similarly, if you see at the tubular heat exchanger like small tubes or large tubes, so the product quality you get here medium to poor, and the aroma retention, however, it is better here. Energy saving is also maybe fair to poor. The capital cost in the small tubes is medium, large tube is low, and the turn down is also good. So, from all other points, if you see that overall, it is seen that the plate heat exchangers, they give fairly good product quality. Aroma retention is also good here. Okay. Energy saving is excellent. Okay. Cost required is also less. Space requirement also is excellent and good, reasonably good. Okay. And then this turn down period is good. So, one obviously depending upon the product, its characteristics, so one has to get a suitable heat exchangers. Okay. Then it is given that in the heat exchanger, material is heated to the desired temperature, desired degree Celsius, 130, 140, 170 as the case may be. Okay. So, and that how much heat is to be applied, one can calculate the equations that we gave. Then from that heat exchanger, it is conveyed to the holding tube. So, obviously, as you can see here in the figure, a holding tube is an unheated section of the piping system that leads the fluid from the heat exchanger for heating to the heat exchanger for cooling. So, that from the heat exchanger it is taken that is it is holding tube holds the material for desired period of time, and then it sends to the cooling. So, the holding tube is where the product achieves the predefined lethality, because required period of time. So, additional heat cannot be applied in the holding tube. So, the material temperature cannot be increased in the holding tube. So, material is already brought down using the in the heat exchanger to the desired temperature, and then it is held in this tube for the desired time. Okay. So, but it can so happen that there may be heat loss in the holding tube. So, holding tube should be properly insulated. So, proper care should be taken, it should be protected to avoid any sort of heat loss, etc. So, flow rate, diameter and length of the whole tube dictate the minimum temperature at the end of the whole tube that is needed to achieve the targeted sterility, targeted lethality. So, one can calculate that what is the time of residence. As I told you, it is very important, that is to avoid any under processing or over processing. The proper residence time in the holding tube is it must be accurate, because here time are generally these are the UST processes, the time is very short to the fraction of minutes or a few seconds. So, that should be very accurately calculated, accurately maintained. So, time of residence is set by the volume of the holding tube and the rate of fluid flow delivered by a positive displacement pump, and the various equation like T average time, T average is equal to AC L by Q, or it may be T average is equal to L by B average, or B average is equal to Q by AC. So, these formulations can be used, where T average is the average fluid residence time, AC is the cross sectional area of the holding tube, L is the length of the holding tube, Q is the volumetric rate of the flow, and V average is the average velocity. So, that is now the flow, depending upon the fluid characteristics, it may follow laminar flow, or it may follow turbulent flow or viscous flow, etc. Okay. But normally the laminar flow is very rare in case of fruit juices, etc., unless it is a very clear and clarified juice. So, particularly when the product quality is the main consideration, the holding time must be based upon the mean velocity rather than the fastest particle velocity, because if you calculate the time, holding time, residence time on the basis of the fastest particle velocity, then the slowest moving particles, they may be over processed, or there may be under processing or over processing cases may be there. So, the measured mean residence time is twice the residence time for the fastest particle to travel through the holding tube under laminar flow conditions. Okay. So, always for quality consideration point of view, average, that is the average velocity, mean velocity should be considered for calculation of the residence time. So, for a turbulent flow, the maximum velocity V max is assumed to be 1.25 times the average velocity B average, and in the laminar or viscous flow, that as in the case of non-Newtonian fluids like sauces, soups, pulps, concentrate, etc., that is they exhibit viscous flow or laminar flow. Here B average is 1/2 of the B max. So, these things could be used, that is flow behavior through the pipe and liquid and other characteristics, to calculate the what should be the residence time. Okay. So, after it is held in the residence time, then it is further conveyed. So, there are like other accessories in the processing line like divert valve. A divert valve is used to direct the product existing the sterilizer away from the aseptic tank and filler in the event that the upstream product is not sterile. For example, a temperature drop in the whole tube. So, this device protects the aseptic tank and filler from contamination. Then there is the aseptic surge tank. Aseptic surge tank is provided in this processing line, okay, and they are used generally to temporarily hold the product while filler is not running and filling the product in package. So, from the whole tube the material is taken and it is put into the aseptic surge. So, sterility of the aseptic tank is maintained by keeping a positive sterile air or nitrogen pressure on the top of the product. Then air filtration, very important. Sterilized air by filtration is used to maintain the commercial sterility in critical areas of the aseptic system, because whole environment, that is, should be contamination free. So, critical areas are those in which the air contacts the sterile product or sterile packaging environment, which are therefore a potential risk for microbial post process contamination. So, that is very important, that is the sterile environment. So, using sometime clean air or air should be properly filtered. So, the critical locations where sterile air is needed in the aseptic processing facility include overpressure of the aseptic process tanks, overpressure of the sterile zone of the aseptic packaging equipment, heating or drying of the packaging materials, head space injection into packages, or blowing performed and transport of the bottles. Then air filtration, it's maybe that is the cartridge filters for air sterilization, or HEPA filters can be used. That is HEPA filter generally gives 99.96% efficiency at submicron size, like maybe 0.3 micron particles, etc., at which they provide the air free of viable contamination, okay, in the aseptic filling lines. So, mostly the HEPA filter system is used in the aseptic processing lines. Then aseptic filler is another very important component. It is the heart of the aseptic operation. In brief, the packaging materials are sterilized using appropriate methods and systems, and then the product is filled and package is hermetically sealed before exiting the filler. So, the sterility of the filler is maintained by positive sterilizer air pressure. Okay. So, this is the aseptic filler. Now, so we have discussed so far the aseptic processing of the product, its various components, and then this aseptically heated product, cooled product is sent to the packaging line. So, let us discuss about the aseptic packaging components. So, the packaging material, obviously commercially sterile products are expected to have an extended shelf life, hence the packaging material should be impermeable to gases, water and other vapors. If it should provide effective barrier in transmission of light, it should be inert, that is, it should not impart any flavor or taints to the packaged product. It should be resistant to chemicals, radiation and heat treatment which are used generally for sterilization of the packaging material. It should be capable of hermetically sealed to provide barrier against microbial contamination. It should withstand insect damage, it should resist deteriorative changes, relatively less expensive it should be, and more importantly it should be easily disposable. Okay. So, among the different packaging materials which are used, there is one is the metal container, which has been used from the beginning of the commercial development of the aseptic sterilization process, as it has almost all the intrinsic properties which we mentioned in the earlier slide. But the major limitations for the use of the metal containers relate to their package geometry and relatively high cost. Okay. Glass containers, they also have the similar properties as to those of the metal container as far as the characteristics requirement of the packaging material is concerned, but they have additional disadvantage of being fragile and of very high density, very high mass, etc. So, mostly the polyethylene and polypropylene nowadays, particularly aseptic processing, that is, they provide consumer, that is the various attractive packages, flexible packages in different forms, etc. So, that is flexible packaging material like polyethylene or polypropylenes, etc. They are being thermoplastic, are used for producing bottle packs. The bottle may be either pre-formed or made just before filling in the blow, fill and seal equipment. Then the co-extruded laminate, there has been addition now, in fact co-extruded laminate, because the whatever in the earlier slide we saw the characteristic of the packaging material, except that glass and metal, no other single plastic material has all the desirable characteristics listed earlier. So, they are co-extruded. So, co-extruded laminates, that is one or more plastic material having complementary characteristics, or even their plastic, aluminum foil and paper in different layers, they are co-extruded. So, the aluminum foil is used in lamination with the plastic film, it improves barrier properties, gas barrier characteristics of the package, and the paper provides the physical resistance, it also provides that area for the labeling, etc. of the package. So, the co-extruded laminates may be 4 layer, that is Tetra Pak, you see it was earlier 4 layer, now 6 layer up to 8 layers. packed laminates are being used depending upon the characteristics, barrier properties, etc. What are the material and the inside how it is being packed, and all those things. So the aseptic packaging systems, there are various paperboard, carton systems or bottle systems, cup systems, pouch systems, and all these are prepared by different setup, either using a farm fill machines, or there are pre-farm systems, etc., which are used. Okay. Now paperboard carton system, seal prefabricated cartons. Here the pre-farmed brick cartons or sleeves are manufactured from the packaging factory by being die cut, creased, completed, sealed longitudinally and distributed at the platform. The fill seal aseptic filler is used to process aseptic food products in the carton type. When package are fed into the filler, the sleeves are lay flat from the cartons are shaped and then sealed at the bottom just before filling step. Both outside and inside carton spaces are sterilized by the combination of 35% solution of vapor H2O2 and hot air. Okay. Then farm fill seal cartons. In this system, the paperboard carton enter the aseptic farm fill seal machine in the form of roll stock web, and the web paperboard carton is fed into the aseptic machine and is sterilized by H2O2 bath, that is 30 to 35% concentration hydrogen peroxide. It is then formed in the box by the longitudinal seal. Hot air is used to remove H2O2 from the material surface before filling. So that is FFS making cartons. Then bottle systems, they may be made by blow mold fill seal bottles or fill seal pre-formed bottles. In blow mold fill seal bottles, there is a dry contamination sterilization technique is applied to sterilize PET pre-formed before transferring to the blowing system with lower amount of H2O2 vapor. This results in much lower consumption of H2O2 per bottle as compared to the pre-formed bottle system. Heat from the oven of blow molding process provides the opportunity to remove H2O2 residue from the material before forming the container, and the system is a continuous process for which it is more complicated to maintain the aseptic zone than comparable with other aseptic filling machines. In the fill seal per pre-formed bottle, normally HDPE or PET can be pre-formed as a ready to use containers. They are sterilized using H2O2 vapors, and in this aseptic system, packaging geometry, amount and uniformity of H2O2 vapor delivered from each nozzle and the flow distribution through the bottle interior are very important factors to be considered. Then cup systems are there. Thermoform fill seal cup. In this system, roll stock of high impact polystyrene is fed into the aseptic filler to thermoform the container shape, and then it is filled with the sterile product before sealing the cup sterile lidding film. Self sealable coffee creamer and cold brew coffee in the cup style containers are processed from this system. Then fill seal the pre-formed cup. It is similar to the aseptic fill seal pre-formed bottle. So the plastic cups which are already formed as a container are used for filling and sealing process, and 35% concentrated H2O2 is used as a sterilizing agent, and it is used for fruit conserves with fruit pieces. Then pouch system or other popular systems, that is they are fill seal pre-formed pouch. That is pre-formed pouch is typically made from multi-layer of aluminum laminated film. They are completely sealed, that is all sides, under clean environment to maintain the microbial contamination, and then pre-sterilized by irradiation process before shipping to the food processor. This flexible pouch is generally packed as a roll stock for individual pouch on the rails. Then pouch systems are also fill seal pre-formed pouch for bulk processing, that is for aseptic bag in box system, the pre-formed pouch which is available in different gallon sizes with filament attachment on the pouch to provide the convenience are used. Okay. And these are normally pre-sterilized by irradiation. These are different fitment styles depending upon the applications. The filling operation depends upon the filament styles. Okay. So, in the fitment is attached with a cup, then the cup is removed after sterilization and recapped after filling. For the spout and double membrane, the filling nozzles punches through the outer membrane, fill the product inside and bag, and then inner membrane is heat sealed by the machine. Form fill seal pouch, in this, that is the web of the laminates or PET polylaminates roll stock is used to fill and seal the aseptic pouches. Roll stock typically moves through a heated H2O2 bath to sterilize them, and then the outer surface of the pouch, and then it is dried with sterile air before it is formed, filled and sealed in the aseptic zone. And they are very popular. They have become now form fill seal machines, FFS machines, which is commonly told. Okay. Now, that is with this system, another very important is the sterilization of the aseptic packaging materials and the equipment. So, generally heat is used, okay, for the sterilization of the aseptic packaging system and the materials. The product supply lines and fillers are commonly sterilized by heat. So, dry heat in the form of superheated steam or hot air may also be used to sterilize equipment, although most commonly it is the moist heat in the form of hot water or saturated steam under pressure is used. So, however, due to relatively high dry heat resistance of bacterial spores, the time temperature requirement for dry heat sterilization are considerably higher than those for the moist heat sterilization. Systems employing moist heat are sterilized at a temperature ranging from 120 to 130 degrees Celsius, or to be precisely 121 to 129 degrees Celsius, while 176 to 232 degrees Celsius is used for sterilization by dry heat. So, sterilization of air by incineration usually is considered at temperatures ranging from 260 degrees Celsius to as high as 315 degrees Celsius. Then chemicals are also used, like hydrogen peroxide is the overwhelming choice used as a chemical sterilant. Other chemicals which have been used as sterilant are the acidic use, that is various acid, ethanol, ethylene oxide and peracetic acid, etc. Hydrogen peroxide, is not an efficient sporicide when used at room temperature. So, the sporicidal activity increases subsequently with the increasing temperature. So, a combination of hydrogen peroxide and temperature is used. Most aseptic packaging systems use hydrogen peroxide maybe 30 to 35% as a sterilant for packaging material, followed by hot air 60 to 125 degrees Celsius treatment to dissipate the residual hydrogen peroxide. Okay. Radiation, gamma irradiation can also be used due to the penetrating power of the gamma irradiation. Packages are treated in bulk at commercial irradiators. So, a dose of approximately 1.5 mrad is common. Dosage required to sterilize containers for the use with low acid foods are considerably higher than those required for the high acid or acidified food. So, average microbial count on a plastic food contact surface ranges from 0.3 to 10 organism per 100 square centimeter, that is reported. So, accordingly the sterility should be calculated, that is risk of defective for sterilization of the packaging material. So, there are reports that on a polythene food contact surface of paper board based laminate, immediately after its forming, the packaging material average total count is 2 to 5 per 100 square centimeter, per 100 centimeter square, and of which 10% is yeast, 20% is generally mold, and about 70% is bacteria. So, the data 4 to 5 decimal reduction are considered necessary to ensure that the spoilage is not in excess of 5 in 10,000 containers. So, the risk of defective can be calculated, and the value of R should be maintained below 5, that is 5 in 10,000, that should be. So, R is equal to N0 multiplied by S multiplied by 10 to the power minus T by D. So, N0 is the number of most resistant organism per square centimeter of the food packaging contact surface, S is the food contact area, T is the time of sterilization process, and D is the decimal reduction time of the most heat resistant organism. Okay. So, with this I have given you a complete overview of the aseptic processing and packaging system. It is very important that is these aseptically processed and packaged materials are stored, that is, although they have good stability under normal atmospheric conditions, but the sealing etc. should be proper, that is, the residence time in the sterilization must be ensured, packaging material must be properly ensured, that is, packaging should be properly sterilized. So, both the product and the package properly sterilized, and then they are in the aseptic environment. This is the package. Okay. Then now these are the references which were used in this lecture. With this, I thank you very much for your patience here. Thank you.